Here's a couple of example problems for circuitry, one in series, one in parallel. Here is a series circuit. It has a 9-volt battery with a 3 ohm resistor and a 1 ohm resistor, and I've gone ahead and set up the chart. First thing you want to do is fill in all of the given information. So we'll start with 9 volts, and then resistor 1 is 3 ohms, and resistor 2 is 1 ohm. And from here, we're going to go ahead and try to complete the rest of the table for the series circuit. The properties that you want to keep in mind is that the current will be the same across each component in the circuit, and that the voltage will add up. So if you add up the voltage drop across each component, that will equal the total. The good thing about series is in resistance, everything adds up as well. So the first thing I'm going to do actually is go ahead and add up the resistance. I have a 3 ohm and a 1 ohm. So I end up with a 4 ohm resistor. And then to get the current, using my equation V is I times R, I'm going to go ahead and solve for current, which is V over R. So that's 9 divided by 4. 2.25 amps. So this is amps, this is volts, this is ohms, and this is watts. And like we just said, current is the same everywhere. So I can go ahead and plug that in for that whole column. 2.25 amps. From here, you're going to go ahead and calculate the voltage by using Ohm's law once again. V is I times R. And so I'm going to do I times R and I times R all the way down. So 2.25 times 1 is 2.25, and 2.25 times 3 is 6.75. And if you look, 6.75 plus 2.25 is in fact 9 volts. So that's where the 9 volts is getting distributed. You can see that the 3 ohm resistor is taking more of the voltage than the 1 ohm resistor, by a factor of 3, actually, if you look at that. If you're comparing this resistance to this voltage and this resistance to this voltage, I want you to notice how those things are related. To find power, you're going to go ahead and just take current times volts and fill in that end column. So I'm going to do 6.75 times 2.25. I get 15.1, really more like 15.2. And 2.25 times 2.25 is 5.1. And 9 times 2.25 is 20. So I rounded some of those numbers. And that's how you would complete a series circuit using a 3 ohm resistor, a 1 ohm resistor, and a 9 volt battery. If I take those same components and I wire them into parallel, then you get the configuration that you see here, where each branch is able to make its way back to the voltage supply independent of the other branch. So again, we're going to use Ohm's law, V is I times R, and the power equation, which is I times V. And let's go ahead and start by putting in the information that was given to begin with, which is 9 volts, 3 ohms, and 1 ohm. Now the thing that you want to do first in a parallel circuit is know that the voltage is the same everywhere, and that the current adds up from branch to branch. So since the voltage is the same everywhere, I'm going to go ahead and plug in 9 volts for each of these. And then from there, I can use Ohm's law to find my current. So I know that current is going to be voltage over resistance. So I'm going to do 9 over 3 and 9 over 1. 9 divided by 3 is 3, 9 divided by 1 is 9. And like we just said, current in a parallel circuit adds up. So 9 plus 3, we have 12. To find the resistance, we're going to go ahead and use Ohm's law again. And for resistance, you have voltage over current. So I'm going to take 9 over 12. And that current is 0.75. So you can see that the current here is significantly less than the current was in the series circuit. And you can rewind the video to compare how the current, the resistance, compare to the series circuit. So the resistance here is significantly less because we have more branches. We have 2 branches that each have their own independent path back to the voltage supply, and so the resistance is significantly reduced the more branches that you add. To find power, you're going to go ahead and just take current times your voltage. And so we have 9 times 3 here, which is 27, 9 times 9, which is 81. And just like with the series circuit, you can go ahead and add up your power as you go to get your total watts. So 108 watts is the total power, 81 watts, 27 watts. And that is the parallel circuit.